Long time ago I didn't write an if here, I write all the other code for resurrecting a node, but I didn't write that if its new y is too big, it should be moved to a smaller y. Perhaps I should write something like this. Let's move in the upper corridor if our y is too big, if we're under the bottom corridor. Let's see how this works. This was the working part, and now I hope we have the top corridor. Instead, it's not working. So perhaps some of you see my book, perhaps some of you know that I didn't show you enough our game. You can see that actually the node is resurrecting, but we have to wait some time, and this is really strange. And some of you totally don't understand what is going on and why this if is resurrecting nodes in the upper corridor, but in a strange moment with strange delay, or perhaps whenever this if likes. So even if you understand everything that I mistaked, try to forget it, and let's try to find my book, and let's try to understand what exactly the computer is doing, just like we will when we really have a bug that we don't see. So I don't know my bug, and I'm going to do everything I could to understand what is going on. One thing I could do is to try to understand what is node y in this moment, so I can write it here, but I was too slow and I have to wait for the next time node y is in this strange condition and my node is invisible. There is one more thing I can do. Both will be a good hint what is happening. So if I write here console log moving to top corridor now, let's see when this is going to be printed. It should have been printed already, but now with such a big delay it happened. So let's try to see what is node y now. It's 600. So apparently the node can stay on y 600, and what actually happens is that it moves from here, from the right part of the field to the left part of the field, normally in a fourth corridor, in a corridor on y 600. This is totally not what we wanted. We didn't need such a fourth corridor yet, and we totally don't need it to be on y 600. My mistake is that this code is executing too late. I want it to be executed earlier. So not when the node is higher than 600. Let's try to think of a different check for this if, so that the node can be resurrected in the top corridor earlier, one passing from right to left earlier, one resurrection earlier. So if we put here this sign or any other sign that we will check if we are with a higher y than all of the canvas size 600, everything is now starting to work just fine. I hope you like this. And this was the smallest problem that we had. I hope that a lot of you has already written such an if. Now that we have it, let's delete it and also delete the previous line and swap all of this with some other code that will choose a random corridor for our node. If you just write node y equals Math.random, this is totally not a good idea, because as you know, this will be a random number between 0 and 1. So all the nodes will look like they're in the top corridor. But if we really wonder what is their node y, it will be not 0, not 1, something in the middle. This will have one more problem. I already had a code that can check if we catch the node. We written it in the end of lesson 4. It was pretty simple check and it was working perfectly for exact corridors. So if I write if my y equals node y, now that I say equals, you saw me that I written only one equal sign, and this is totally wrong. I remind you, when we want to check such a thing, we need two equals signs. And now I can check if my y is equal to node y. So only in this condition we can write you got it. This is not a thing that should happen just like I did it on each update, because you can see that I got the node not only when I really collide with it, now and now, but even when it's far to the right from me. So this is I think that this is a thing that I should write in this if. And this is wonderful if that will work only when I catch a node, and will not work. You can see that it's going to be only two prints of it, only the first print. So it's not going to be printed anymore if I miss all the following nodes. This is a perfect if that will stop working if node y is now not 0. If it's, for example, a random number between 0 and 1, it may look like the node is always in the upper corridor. Now I got the node because it was on exactly 0 like in the beginning, but you can see that I will never see you got it again, because now the node will be only on random y's between 0 and 1, and those numbers aren't exactly the same as 0. So putting the node on exactly a random number between 0 and 1 is a bad idea. We already had stranger and more complicated ifs when we used Math.random to choose a random corridor out of two corridors. And perhaps we will need something like this now too. In other games we will be able to choose. Не, трябва да махнем изречението, започващо с in other games. Добре, махаме го и сега започвам изречение, което да си го продължиме, с което да си продължим записа. So the ifs that I will write will check if we should put the new node on y0 or we should put it on y200 or we should put it on y400. I hope that I write such a condition in those round brackets that on each node resurrection, when I put it on the right end of the screen, I will also choose a new random corridor with equal probability. It will be stupid if one of the corridors is more probable or if there is a higher or smaller probability to be in the same corridor. I hope that I write such a thing that my three corridors will be equal for the node. So one thing I can do is to check if Math.random is smaller than 1 divided by 3. 1 divided by 3 is one of those special numbers that are between 0 and 1. If you are really small, perhaps you haven't learned such things in math class, but I hope you understand them well enough now, and because we are going to write even more such examples. There is another thing that it's easy to check if a random number is higher than 2/3. This will mean we should go in the bottom corridor. And the hardest part again is about the middle corridor. Perhaps we will again need two ifs. Perhaps we will again need two nested ifs. Мисля, че вложени на английски е nested. Използва се за цикли, за ифове. И трябва да... Не е това думата, може да го гугълнем после. Да. So, if I'm going to write two nested ifs, you can see that I will write them in a really specific way with a lot of blank spaces before my most important line go in the middle corridor. And those two ifs will check if a random number is higher than 1/3 and is also smaller than 2/3. So if both those conditions are met for one random number, the new node should be in the middle corridor. Let's see if now we have random and interesting corridors. In order to have a good view over a lot of resurrections, I will make the nodes move really faster. So I can see a lot of nodes being resurrected. And I can see that nodes are appearing in all of the corridors. But I cannot be sure if the probability of each corridor is equal. One of your more difficult tasks for your homework will be try to think of a way to test the probability that we written. Try to count all the resurrections in all of the top corridor, in the middle corridor and the bottom corridor. And if over a long time those statistics are much different, then apparently we have something wrong with this code. I will admit that I intentionally make a mistake, and it's kind of a hidden mistake, so you will need a lot of thinking to understand what really is going on and why some corridors are more probable than other corridors. But this is not our most important task for now. You have more tasks, and perhaps they are all easy, and they will make our game, now that it's kind of running, those are tasks that will make it much funnier and interesting to play. So tasks that you can now start are not only write "you got it," but also count the number of times you got the node. Also count the times that you missed the node, and perhaps this will cost us a life. Also make each node faster, not exactly starting from speed 30, but we can increase the speed. All those tasks are already done in the previous homework, so it will be really easy for you just to take our approach from the previous lesson. And when you are ready, you can start testing how this code is really choosing corridor for our new node. And if you can, try to think of a new way to count. Try to think of a new way to choose a corridor for the node.